Hey guys! In this video on operating systems, we are going to cover all types of scheduling algorithms. This is Anushka Upadhyay, a student from Bennett University. So let's discuss the topics we are going to cover in the video. I will be telling you about process scheduling algorithm, preemption versus non-preemption, what is arrival time, burst, completion, turnaround, waiting, and response time in CPU scheduling. First come, first serve CPU scheduling algorithm, round robin CPU scheduling algorithm. So let's get started.
Hi guys, so let's start with process scheduling algorithms. So you enter a bank and stand in a long queue, assuming that queue is a ready queue and you being a process and the clerk is the CPU, and then you wait for your chance to come and meet the clerk, that is the process meets the CPU. All this scenario when the process is selected and sent to the CPU for execution is called process scheduling algorithms. So there are two types of process scheduling algorithms, preemptive and non-preemptive. So preemptive algorithms, when one process like one customer is sent to the clerk and we assume that another customer who has some kind of emergency and wants his details to be filled in fast. So the clerk sends you back to the queue and takes him as the priority. This process of sending one process back and forth from the running state to the ready queue is called preemptive approach. Non-preemptive. Once a process is sent to the CPU, it has to terminate and execute everything, and then only another process will go. So this is the non-preemptive approach. So next comes the basic terms which you need to understand before we move further. Arrival time, burst time, completion time. So what are these times? Suppose you enter a bank at 12 o'clock. That is your arrival time. The point of time, 12 o'clock, is your arrival time. Then after some time, when you interact with the clerk and your procedures will be going on with the clerk, suppose it takes 15 minutes for all of your procedure to be completed for opening a bank account. So those 15 minutes is your burst time. And then after you are done with everything, you pack up. And at point of time when you leave the bank is called completion time. So what's the turnaround time? As the word suggests, the turnaround. The whole time you were in the bank is called the turnaround time. It can be calculated by subtracting completion time with arrival time. And then comes the waiting time. So waiting time is a time when you were filling the form, when you were standing in the long queue, all those time when you were not in the process with the clerk. That is your waiting time. So it will be calculated by subtracting turnaround time with burst time. Now, what is response time? For the first time when I interacted with the clerk, that point of time minus my arrival time at which I entered the bank. That will be my response time. Okay. So next comes first come first serve CPU scheduling algorithm. As the name suggests, the process that will arrive first will be executed first. Simple. The mode used here is non-preemptive. You should remember this. Non-preemptive mode suggests that once the process is sent to the CPU, it cannot return back. It has to be fully executed. Then only there will be space for the next process to go to the CPU. In this, processes will be given to you, arrival time will be provided to you, and burst time will be provided to you. You have to find out the completion time, turnaround time, waiting time, and response time. Okay, so there you have to create a Gantt chart where you define the timeline and the processes that are occurring. So supposingly at time equals to 0, process number 1 arrives at time equals to 0. So its burst time, it will execute for 2 units of time. So plus 2 is equals to 2 units of time. It executed process number 1. Then between 2 units of time, did any other process arrive? We have to check this. Yes, at 1, P2 arrived. Nearly about this point, P2 arrived. So P2 arrived at point number 1, but it will be executed after P1 is completed. So from time 2, P2 will start and P2 will execute for 2 units of time. So 2 plus 2 is equals to 4. Then till 4, did any other process arrive? No. So we'll leave this blank. So this is important thing if you consider. At 4, no other process arrived. So till 4 to 5, we leave it blank. Then at 5, did any other process arrive? Yes, P3 arrived at 5. So, and it executed for 3 units of time. So 5 plus 3 is 8. P3 executed. Then we see if any other process arrived. Yes, P4 arrived at 6. Nearly about this time, P4 arrived. So from and its execution time is 4. Burst time is 4. So 6 plus 4, 8. Sorry, 8 plus 4 is equals to 12. P4. So all the processes are completely executed. This we can see. So what is the completion time now? The completion time is the time when the process is fully executed. So for P1 it's 2, P2 it's 4, P3 it's 8, and P4 it's 12. Already I have written it to make it simpler for you guys. Then we calculate turnaround time, which will be calculated using completion time minus arrival time. Completion time 2 minus 0 is equals to 2. 4 minus 1 is equals to 3. Similarly, you can calculate others. Waiting time will be calculated by subtracting. Waiting time will be calculated by subtracting turnaround time minus burst time. So 2 minus 2 is equals to 0. 3 minus 2 is equals to 1. The response time will be calculated by subtracting when the process first met the CPU minus arrival time. So the P1 first met the CPU at 0.0 and arrival time of P1 is 0. 0 minus 0 is 0. Similarly for P2, 2 minus 1 is 1 and rest is 0. Now you can see one thing. Response time and waiting time for all the given processes is same. Why is this happening? Because of the mode, which is non-preemption. So we do not need to calculate response time in non-preemption mode. Now next question that can be asked to you will be of average turnaround time or average waiting time. All you need to do is add all these and divide by 4. Similarly, add all these and divide by 4. Round robin CPU scheduling algorithm. Process will be given, arrival time will be given, burst time will be given. Remember, the mode here used is preemptive, which means that once the process is sent, it can be returned back if a process of higher priority shows up. And criteria followed is time quantum. Time quantum in round robin questions will be provided to you, and here it is 2, which means it doesn't matter whatever the burst time be, the process will execute, each process will execute for 2 units of time. Now we have 2 queues. One is ready queue and second is running queue. At time is equals to 0, P1 arrived in the ready queue. At time equals to 0, P1 arrived in running queue. Okay, so P1 will execute for 2 units of time and here 3 will be left. Then we see that till 3, did any other process arrive? Yes, P2 arrived and P3 arrived. P1 arrived, P2 arrived at 1 and P3 arrived at 2. So P2 is in ready queue now and P3 is in ready queue. P1 is executed, so we will cut this and then we see, is P1 left? Yes, P1 is left. 3 units of time is left. So P1 will again come in the ready queue. Okay, now P2 will execute for 2 units of time. Is P2 left? Yes, 2 units of time left. So we will cut P2. So till 4, did any other process arrive? Yes, P4 also arrived at 4. So we'll consider now first P3 and then P1 was already in the queue and then P4 is in the queue, and now after P2 is cut, we'll add P2 over here also. So from P3 will execute for 2 units of time till 6. So we'll cut this and P3 is fully executed now. We can cut whole of this P3. Okay. So then we see which is in the queue now. P1. P1 will again execute for 2 units of time. Okay. So P1 is 1 left. Then we see which is P1 again left. We'll add P1 at the last and cut over here. And now we see P4. This is an important point now. P4 burst time is 1 and time quantum is 2. So we cannot execute P4 till 8 to 10, which is wrong. We'll execute P4 from 8 to 9 because its burst time is 1. Then is P4 left? No, P4 is totally done. Now we have P2 and P1 left. P2 will execute for 2 units of time and then it will be done. So P2 executes from 9 to 11 and then P1 is left 1 and it will execute again for 1 unit of time and the whole Gantt chart we'll obtain. Now we'll see the completion times, turnaround times, waiting times, and response time. So the most important thing over here is the completion time will be seen from backwards, not from the front. Because if we consider P1 completion time, you can see P1 is completed here also at 2. P1 is completed here also, then it comes P1 comes here also. So this 2 or 8 is not the completion time of P1. Completion time of P1 is 12. So we'll write over here 12. Completion time of P2 we see from last, it's 11. So after that we'll see turnaround time, completion time minus arrival time, 12 minus 0, 12, 11 minus 1, 10, waiting time, turnaround time minus burst time, 12 minus 5, we'll consider the original burst time, which was 5 in this case and 4 in this case. So 12 minus 5 is 7 and 10 minus 4 is 6. Now response time we calculate the first time when the process met CPU. So you see P1, for P1, P1 met CPU at time equals to 0. So 0 minus arrival time 0, it's 0. Then for P2, P2 met at 2. 2 minus 1 is 1, we write 2, 1. And then for considering P3, P3 arrived at 2 and P3 first met CPU 4. So one more important point that comes over here is the concept of context switching. So what is context switching? Basically, in layman terms, context switching means one process goes and another process arrives. So in this case, process number 1 is going and process number 2 is arriving. See the Gantt chart. Process number 2 is going, process number 3 is arriving. Process 3 goes and 1 arrives. So all these walls where the switching of processes is taking place is called context switching. So a question can be asked like how many context switches are in this question. So you will write 1, 2, 3, 4, 5, 6. So your answer will be 6. You won't consider the startings and the endings because at these points no switching is taking place. So all right guys, we have covered almost all the questions related to first come first serve and round robin in this video.
Hope you guys enjoyed the video. Thanks for watching. Stay home, stay safe, and take care.